Physics chapter 17 theory video 6. We are going to learn about centripetal force. Before we discuss what exactly centripetal force is, let's remind ourselves about the first and the second rules of, or the laws rather, of Newton. Newton's first law says unless there is an external force acting on an object, it will either remain stationary or will travel in a straight line at constant velocity. Then the second rule is the F equals ma rule. That is, if there is a force, there is an acceleration. Or if an acceleration is there, there has to be a force. So this relationship is quite important for us to understand how centripetal force works. Now, if you take a motion in a straight line, now if you take something to be moving in a straight line, so let's assume that it is moving in this particular direction with a velocity of v. Then if there is an acceleration, if a force acts in the same direction, then it would get an acceleration based on this equation. So now let's assume that something is moving at a speed of 10 meters per second. So let's say that something is moving at a speed of 10 meters per second in this direction. So if it has an acceleration of 2 meters per second squared, what does that mean? It means that each second that passes by, 2 meters per second will get added to this. So that means after the first second, the velocity is going to be 12 meters per second. After the second, it is going to be 14. After the third second, it is going to be 16, like that. Right? So that is what it means. So when in straight line motion, if there is an acceleration, the velocity is going to change. This velocity is going to change. But now we are going to look at something entirely different. We are going to look at how centripetal force, that is, there is a force, so as a result there should be acceleration. But in circular motion, even though there is a force acting on it, even though there is a resultant force acting on it, the numerical value of the speed will remain constant. So we are going to figure out how and why. So now let's take this situation. A rubber bung is attached to the end of a string and it is being rotated. So then if you do that, you will actually realize that there is a pull on your hand. So that means there is a force acting towards you. So this force, this tension is towards you, the tension on the string. So that is the force that is acting. So there is a force, there has to be an acceleration. So now let's try to figure out how this affects the movement. Now in this circle there is a central point, and then you have you are making this this is the string and there is a force acting towards you. So then that means the acceleration should be in the direction of the force, that is towards the center. So now at this particular point, at this moment, this object is moving in this direction. At this moment, now let's say this is the rubber band, it is moving in this direction. So then why won't it accelerate in that direction? Think about the components of the forces. So when you think about the components of forces, the acceleration is towards the center. As a result, there is no component in this direction. But at the same time, it is moving towards the center. So as a result, it is being pulled. As a result, it changes its direction with time. So at each point, it is being pulled towards the center. At any given point. That is the reason why it is traveling in a circle. At any given point, it is traveling around the circle because it is being pulled towards the center. It is always being pulled towards the center. That is the reason why it continues to travel in a circular motion. I hope you understood that. So when the earth is orbiting the sun, the gravity of the sun keeps us in our orbit. So we are being always continuously pulled towards the sun. Just imagine that we lose this force. Suddenly we lose this force. Now just imagine that this is the sun, and the earth is orbiting around it. Let's say this is the earth. What would happen if the sun was to disappear all of a sudden? At this point, if the sun was to disappear, then what would happen is there wouldn't be any force to pull us towards this. So we will continue to travel in a straight line because there is no external force acting on it. If there is no external force acting on it, it will travel in a straight line. So because this force traveling in this direction, it will continue to travel in a straight line. I hope that made sense. This force that makes something accelerate towards the center, so that acceleration actually changes only the direction because it has no component in the actual speed of it. So it is continuing to travel in a circle. At the same time, it is always accelerating towards the center. Because it does not have a velocity towards the center, it won't crash into the center of the sun. So the earth does not crash into the sun because there is no speed towards that. But it is traveling in a straight line, but because of this acceleration, it is going in a circle. So this force is known as centripetal force, and because centripetal force is actually, it is a description. It is here they are saying that it is an adjective. So because of that, it is not actually the noun. It does not say that centripetal force is a thing. There are many different kinds of forces that would provide the centripetal force. It could be, now if you look at the earth and the sun, it is the gravitational field strength. Then if it is the electrons and the nucleus, that is electrostatic attraction. Then if you are now in this example we took the bung being recorded, then it is the tension on the string. If a car is taking a bend, it is the friction between the tire and the ground. So you have to understand which specific centripetal force is going to do that. Right? So here you can understand in this particular occasion, you can see that the velocity is in this direction. But the gravitational pull of the sun is in this direction towards the center. So as a result, it is being pulled. When it is going here, it is being pulled. So as a result, it takes a bend. When it is going here, it is being pulled. So it takes a bend. So like that, it continues to move in a circle. I hope you understood that. Let's write down the note. Write down centripetal force. The force that keeps an object moving in a circle is known as centripetal force. It makes objects accelerate towards the center . However, it will not affect the speed of the object. Leave a line, put a star and write down. Velocity changes because the direction of the movement is changing. If this force was to be taken away, leave a line and write, if this force was to be taken away, the object that had been moving in a circular pathway would continue to travel in a straight line, creating a tangent to the circle, would continue to travel in a straight line, creating a tangent to the circle at the point when it lost the centripetal force. At the point when it lost the centripetal force. So as you can see in this diagram, if the sun was to suddenly disappear, it will travel in the direction of the velocity, that is because there is no gravitational pull. So there is nothing to pull it towards the center, it will travel in a straight line at that point. I hope you understood. If you understood well, please do question number 10 and 11, and then if you have doubts, please raise questions.